Welcome to this session of MATLAB Speaks Hardware. Before we start the session, we are going to share a few tips for the audience. For that, I'm going to share my screen here so that you can see. Let me share my screen real quick. Okay. So a few tips for the audience as we get started. You can adjust the audio video quality in the bottom right corner of your screen to improve streaming speeds. This session will be posted as a YouTube video as soon as the live session is over. So you can review the hands-on demo and other content that's presented today. Feel free to chime in with your questions and comments in the audience chat window, and we'll cover the questions at the end of the session. With these tips, let's get started. This is a session on MATLAB Speaks Hardware, and today's theme is focused on a piece of hardware that we are all too familiar with, the ubiquitous mobile phone. I have Dan Seal and Greg, both from the product marketing team at MathWorks, joining today's conversation. And we will begin with a hands-on demo, followed by an overview of advanced applications from Dan and Greg. This should give you a complete flavor for mobile solution from MathWorks. Little bit about why we picked this topic today. So for that, um, let me get out of presentation mode and show you a website. So why did we pick this topic today? Timing's important, and MathWorks has launched a mobile devices challenge. To participate in this challenge, you need to use MATLAB and Simulink with a mobile device or tablet and share your project in the form of a YouTube video. If you already have an interesting project you built, you can enter the contest just by creating a YouTube video about it. As you can see, there are exciting prizes to be won, including the top prize of $1,000 and obviously long-lasting bragging rights. So we'll help you get started today. And remember, the deadline to submit your entries is June 12th, 2017. So you got plenty of time, about a month from today. So going back to the slides, target audience for today's session are participants in the mobile challenge, faculty who would like to use mobile devices to make teaching more interesting, and of course, students and makers who want to work on cool projects. With that intro, let's jump into the hands-on portion here. So all of us, I'm going to stop sharing the screen for a minute. Bear with me. So all of us have cell phones, right? And many of us have these devices, Fitbit or other activity monitoring watches or tracking devices, right? So with MATLAB and Simulink, we built a simple app that counts the number of steps we have taken. So it's basically a pedometer. And I've installed it on my Android phone here. And I'm going to share my screen to show it to you in action here. So let me start the app real quick, and you will see that as I take steps, it counts the number of steps and increments the number on screen. So I'm going to share my screen. And as you can see, as I take number of steps, the pedometer counts the number of steps and it increments the number of steps here. So how did we get to this point, and how did we create this app using MATLAB and Simulink? That's the topic of today's session, and let's get into that by looking at starting with a MATLAB session. So I'm going to start with the MATLAB session here, and here, whenever you're going to use a hardware support package, you're going to first start with the add-ons section on the home screen and go to hardware support packages. So when you click on hardware support packages, that will open what we call add-on explorer with several hardware support packages that are available to you. I'm going to search for Android here, and I see there are two support packages.
Hey,
So
Anuja,
yeah.
this is Dan. I'm just wondering if maybe you could share your screen again so we can see exactly what you're looking at. We see your camera right now.
Oh, apologize for that. Let me share
It's
my
all right.
screen. Can you see the screen now?
Yep.
Thank you. So here, let me go back real quick. So on the MATLAB home screen, you click on add-ons, then click on get hardware support packages, and that will take you to the gallery of hardware support packages. Here I'm going to search for Android to look for Android support packages since I have an Android phone. And there are two support packages here, as you can see. One with the Simulink support package, you can create apps on Android phone. And with the MATLAB support package, you can collect sensor data from your mobile phone and then process it um, using your phone, using MATLAB. So similarly, if I look for iOS, I'm going to find the similar two support packages for iOS. So I've installed both the Android support packages. So as you can see, I have both these support packages installed. And I'm going to cover the workflow starting with MATLAB support package. And remember that all the steps that I cover in the workflow are also applicable to the iOS support package. The only difference is that the toolchain you will use for iOS would be specific to iOS. For example, for creating apps, in case of iOS, you will use Xcode with a Mac operating system and so on and so forth. So with that, start with the documentation. On the documentation, I would go for the MATLAB support package for Android sensors to begin with. In here, first you have to start with the setup and configuration part, and then we are going to look at examples followed by that. So like any other application, there's a one-time setup process for configuring your Android device. So few notes here for setting up your phone. If you go to the settings for your Android phone, so this is my settings. You can look at um, you can look at some of the settings for developer options. You have to enable the developer mode as well as USB debugging in this case. Also, in this case, you need to install the MATLAB Mobile App, which looks like this, and you can enter MATLAB commands and so on. So with that kind of setup, you also need to install USB drivers for your mobile phone. If you have a Samsung or a standard Android phone, these are available within the support package installation process. But if I have a OnePlus 3, for example, so I had to install the USB drivers separately, which was a pretty straightforward process. And also remember that your Android phone should be on the same network as the computer that has MATLAB installed on it. So these are sort of the requirements for the setup. The setup steps are fairly straightforward, and you can follow these. I basically followed these to set up and configure my Android device. So now if I go back, I'm going to go to the examples. So each support package comes with examples that you can start with. Here we have three tutorials specifically. And the one we are going to start with is counting steps by capturing acceleration data. So this is a tutorial which I followed pretty much line by line to create a MATLAB script that logs data from your accelerator and then plots this data and does some data processing on it to calculate the number of steps and then marks them on the plot of the acceleration data, which indicate when the step was taken in the process. So let's go through the script step by step here. I'm going to open this script, and you may be familiar with the standard MATLAB editor. Here I'm going to open the script in a slightly different format, which is called as a live editor. So those of you who are not familiar with the live editor, it allows you to document the example as well as share MATLAB code and the results resulting from the MATLAB code. So for example, if we execute this command right here, um, this creates a connector that becomes it's like a server that's available from your computer for your phone to connect to your computer. So now I'm opening my MATLAB mobile app and connecting to my laptop from there. Followed by this command, it not only shows the output here, we are going to create a mobile object that corresponds to the mobile device that's on my phone. That's my phone. So I execute this command, and as you can see, this object was created. You can also see it in the MATLAB workspace here, and the properties are listed here, and it's noted that this is connected. Note that the logging is currently turned off, as well as the acceleration sensor is not enabled. So next, we are going to enable the acceleration sensor and also enable logging. Now remember that when we enable logging, as soon as we do that, the sensor starts sending data and we are logging that data. So I'm going to pause that for a little bit and then just walk around. So as I walk around with my phone, it's logging is the acceleration sensor is sending this data uh, to MATLAB, and the data is being logged here through this object. So now I'm going to stop logging the data, and we will look at this data in the form of the a and t variables. T is the time and a is the acceleration data. We create a plot of x, y, and z components of the a acceleration data and plot that as a MATLAB plot. Notice that this has been integrated within the live editor as well. To further process the acceleration data, we calculate a magnitude which incorporates all three components. So we can notice the difference between the different magnitudes, and it avoids, regardless of device's orientation, it can give us a nice data that we can then use for detecting number of steps. So this is what the magnitude looks like for the acceleration sensor data. Now, to remove some of the constant components, if you look at the value here, the mean is not at 0. So we are going to remove any constant effects like gravity from that and plot that here. So we plot that, and then we use the find peaks function from signal processing toolbox to find the number of peaks in this data, and that essentially gives us the number of steps here, which was 6 in this case. Now we plot the number of steps and when they were taken on top of the um, plot that's plotted here. So these are basically the steps that I have followed to create a simple pedometer algorithm using the MATLAB support package for Android devices. Now, before we move on to the Simulink support package, I wanted to show you one more thing which may be interested to the faculty in the audience. With Live Editor, you can save the same file as a PDF or HTML if you wish to share this with your students. And I've already saved this as a PDF, and this is what it looks like. So this is something you can use for your lab material and assignments and so on and so forth. So this is the demo. This completes the demo for the MATLAB support package. Now we are going to move on to the Simulink support package demo. Continuing with the same application for pedometer, what I have done is I have created a Simulink model that incorporates the exact same algorithm for calculating steps. Only this time, the analysis will be done live in the form of an app on your mobile device, and that's why we would need to generate code from the model to create an app for your Android device. Now, before I go into the details of the model itself, I want to give you a quick overview. So, similar to the MATLAB support package, if we go to the documentation page, we can look at the Simulink support package, and there's a one-time setup and configuration step that you need to perform. There is also examples available, number of examples with the Simulink support package. As you can see, the applications range from color detection, image processing, to audio processing, as well as controlling your Raspberry Pi, Arduino devices, or even controlling mobile robots with an Android or iOS app. There's a number of library blocks available, and I'll give a quick tour as soon as I open the model. But this is basically the number of examples available with the support package. Now, to complete the first time setup, you would use this function target updater, or you'll do this as a part of your installation. So this is, we're going to update it for Android. Here it says, how to enable the developer mode on your device. It also explains how to enable the USB debugging on your device. And then it says, whether you have a Samsung phone or a Nexus or a different device. In this case, I had a different Android device. And as I mentioned earlier, I installed USB drivers for the phone. And once I had all this setup done, the installer recognized my phone here, and I followed the next steps to configure it. Now, since I have already configured the device, I'm directly going to open the model here in Simulink. Now, if I look at the library browser for Simulink, I will see a number of libraries depending on the products I have installed. Specifically, I want to look at Simulink support package for Android devices. As you can see, there are a number of sensors that you can read data from. You can also process the data using Simulink and then use output configurations like data display. There are interactive elements like a button or a slider as well available for your app integration. Last but not least, there's integration with ThinkSpeak, which is MathWorks provided IoT platform. And I believe Dan and Greg will touch upon this a little bit. So with that, a couple of notes about this model. We are reading the accelerometer data X, Y, and Z here. Because it's reading live data, we are going to buffer the data before we pass it to the MATLAB function for analysis. If I open the MATLAB function, it's basically the same algorithm that we used here, where we get the magnitude, then remove the effect of gravity, and use the find peaks function to calculate the number of steps. So with that, it and the data display setup, the phone actually displays the number of steps I have taken. And to show you this app, I'm going to go back to my phone. Um, and open this app again. How I take this algorithm and deploy it into an application is simply by clicking this button, deploy to hardware. Once I click this button, it builds the application and it shows up on my app. In addition to the build button for configurations, I would need to set up the hardware implementation configuration parameter here, um, and pick the Android device. So this is the target device in this case. And once I'm satisfied with the algorithm, I press the build and deploy to hardware button to get to the app on my phone. And the app demo I've already covered before, and it can be seen here that as I walk, the number of steps for the on the phone increase, and it starts counting up as I walk some more. So with that, I've covered a hands-on demo of the Android support package for Simulink, um, as well as MATLAB. And now I would like to pass control to Dan so that he can cover some more advanced applications as well as other overview elements I might have missed. So with that, I'll pass it on to Dan.
Hey, thanks, Anuja. That was a pretty cool overview of that application, and it was neat to see how you could do that application both in MATLAB and in Simulink. Um, what I want to do right now is just cover a little bit more detail about how people can get up and running doing some of these things that you're showing. Um, and there's a couple of components. So one of them is in order to get that sensor data off your phone and into MATLAB, you need to have the MATLAB Mobile App, which Anuja mentioned and she brought up on our screen. So I want to mention how you can get that. So let me share my screen real quick. If you just search MATLAB Android on Google, um, the first hit likely on your screen, it's the first hit on mine is MATLAB Mobile, and this is an Android app. But if you are on an iOS device, you can search in the App Store, and you can also find an app with the same name, MATLAB Mobile, as an iOS app. And so when you install that on your computer, there's actually a lot of things that it can do in addition to getting sensor data. It actually can connect to a MATLAB session that's on your computer, and you can use it to run MATLAB code away on your computer and see the results on your phone. You can use it to make plots and figures and see the results on your phone. What Anuja was showing it for was for getting the sensor data. And in order to get the sensor data, then you need the support package, which Anuja showed how to install. And so we also have a web page, the second link here, Android Sensor Support from MATLAB. This has a lot more detail about that support package, which I had installed, or which Anuja had installed um, from within MATLAB. So you can go to this web page and click Get Support Package, or you can do it from within MATLAB and search for that support package that she had installed. And so one thing to note here is there's some cross-links to other pages where you can learn more about how to use Android phones with Simulink, how to use iOS or Android devices with MATLAB, with Simulink, or with MATLAB Coder. And specifically for getting the sensors off from MATLAB Coder, there's actually an image on here which shows what it looks like. Um, so this is the screen that popped up on Anuja's screen on her phone when she went to the Sensors tab. And in her demo, she actually controlled all of this sensor acquisition from within MATLAB. So she did m equals mobile dev and m.logging equals 1, m.logging equals 0, m.acceleration sensor enabled equals 1. So that's a really cool way to do it if you want to do everything controlled from your computer, and maybe the phone has to be in a certain place and you can't be touching the app. But another really easy way to just get the sensors up and running, see what they are, and start logging them is to use these buttons on here in the app. And you can click each of these buttons. So there's an accelerometer, a magnetometer, angular velocity sensor, a GPS location sensor, an orientation sensor. And so you can tap any of them to enable them or disable them, and you can see the actual values on the screen. And then you can also start logging them into your computer the way that Anuja did there. So this webpage has a lot of details about everything you need to know about that and how to get those data from those sensors into your computer so that you can start doing those plots and those analysis and things like that step counter application that Anuja talked about. It
So
also has,
Dan,
yeah.
one question. I know you have developed a video and even an advanced version of the kind of the simple example that I showed of counting steps. Could you talk about that a little bit, where there's more complex activity tracking using these capabilities?
Yeah, so there's actually a few other examples. There's one which we have a link to from this page, activity detection with MATLAB. And this is an example where we're not just counting steps, we're actually tracking the accelerometer data while doing a whole bunch of different activities. In this example, it's someone walking upstairs, someone walking downstairs, running, walking on just flat ground, or just sitting or standing or not moving. And MATLAB has a lot of abilities to do machine learning on different types of data. So if you take a big set of data where you've labeled everything that's been done, you can take a whole collection of doing all these activities and then tag them and then build a machine learning model that will automatically be able to detect that activity in the future. So this whole article goes through that whole process. And we also have a webinar which describes this type of machine learning or data and analytics for sensor data. And if I scroll down through this page, just see some of the results that we get, you can see how the different types of activities are grouped in different ways in this 3D plot. Um, and you can see how uh, at the end of the day, we're actually able to distinguish some different activities. And I think this particular article doesn't show the accuracy of the model that we run at the end, but there's ways to train and to test and to see how accurate and how well the model performs at the end of the day. So it's a pretty cool application using more than just the number of steps. It's actually what type of thing are you doing.
That's great. Thanks, Dan. Also, Greg, could you talk a little bit about ThinkSpeak, the ThinkSpeak integration, and any other specific capabilities for the Simulink support package?
Sure, Nuja. So related to ThinkSpeak, the Simulink support package for Android and iOS both include a library of blocks that can be used to put together different algorithms to run on a standalone or on external mode, what we call external mode, on the phones. And one of those blocks is ThinkSpeak block, which basically makes use of the inputs that we define and puts them on the ThinkSpeak website, on the account, on the channel that you create. You can log in into thingspeak.com, and basically using your MathWorks login or the ThinkSpeak login, create different channels and be able to visualize and log the data from the mobile phones using Simulink. Now, the Simulink libraries for both Android and iOS, they include multiple other blocks that give you access to the sensors on the phone, and also, as you showed earlier, also give you some widgets that you can put on the screen of your phone. The the main distinction between the MATLAB and Simulink hardware support for mobile devices is that in our case, we are completely creating an app for the phone directly from the Simulink diagram without having to write any kind of code. And let me share my screen quickly. We just recently put out that video to overview the support packages, and this is what it does. Uh, Basically, you create your Simulink diagram in this way, and then by clicking deploy to hardware, you basically just create a mobile app, and it can include some widgets and buttons and slider gains, etc., depending on your application. And yeah, I invite you guys to watch this introduction video, but in addition to that, which you can also find on YouTube, um, I have also created a project that takes you step by step through an application in which we control a Raspberry Pi mounted camera and from the Android device, and it includes the files and all the detailed steps you need to follow to just get to learn after you have installed the support package on your computer, all the steps you need to take to develop such an application. And it's a way to learn to get started with the Simulink support packages and to learn how these support packages can be used. We also, from Simulink, we also support a whole bunch of other devices such as Arduino boards, Lego Mindstorms, Raspberry Pi, as I already mentioned. And one of the capabilities included with these hardware support packages are blocks that let you connect those devices to each other via Wi-Fi using either UDP or TCP/IP protocol. You can have, as in this example that I was showing you, um, with a Raspberry Pi and Android control, can just let you control the Raspberry Pi camera from your phone. And I have here a few visualizations that can help describe that. I'm going to show them here. So for example, yeah, these are all the different types of applications that you can develop with the Simulink support packages. Here at the top right, at the bottom right, you have the wireless connectivity using a mobile phone to control a robot. Basically, what we're doing in that case is is having control on the other device by developing, a mobile a Simulink model for each one of the devices, one Simulink model for the phone and one Simulink model for the Raspberry Pi, and setting up parameters in the Wi-Fi, in the TCP/IP and UDP blocks that let them communicate with each other. In this case, we're controlling the camera, as you see here, from the slider gain that we have on the phone. And the camera, the Raspberry Pi is receiving those signals and is controlling a servo motor mounted on this stand to move the camera left and right according to what I do on the phone screen. Uh, in a similar way, the communication is bidirectional. So the video that is being captured by the camera is being processed by the Raspberry Pi and sent over Wi-Fi to the phone. And here you can see our colleague just walking in front of the camera. And as I move the camera left and right, you can see him walking by. Um, Other applications also involve, controlling your Arduino boards. You can turn on and off lights and fans and move curtains. If you want to do any home automation projects, there is something you can use your phone as the interface for the automation portion of your project, and then use the Arduino to just do, the actuation and sensing of your project. Similarly, then you can connect many other devices in a similar way. In this case, I'm showing the Raspberry Pi with a Lego, but because this webinar or YouTube live session is on mobile devices, let's focus on the mobile. So here's another application in which we are controlling a robot by just tilting the phone forward, left, right, and using accelerometer data to just send commands to the robot. And so on and so forth. So this is what I had here for those slides. For
That's
this
great.
particular, yeah.
No,
You have any
no, go
questions?
on. No, there are a few questions in the audience window.
Yeah.
So whenever we get a chance, we can go to the audience questions.
So yeah,
Sorry if I
if
interrupted.
anybody's interested in finding this project here on File Exchange, so search for Control Raspberry Pi from Android device, and on the description you will find the link to the detailed webinar, and also in those files you will find basically everything that I talked about in the webinar, both the Simulink models for each one of the examples, and also the slides that I used for the webinar.
Great. Thank you, Greg, and thank you, Dan. A couple of questions I see here. One question about app development. Can we save the app APK file to use on another phone?
So I think that refers to the Simulink workflow. And if you generate an APK file with Simulink, yes, you can share that APK file with other Android users to install on their phone and run the model as well,
That's great.
without the need of having Simulink. Once you generate the APK file,
Right.
your colleagues don't need MATLAB or Simulink to run the model.
There's also another question that they don't need MATLAB mobile app either, right?
No, they don't need mobile app.
Right.
Right. So Anuja showed two different workflows here today.
Right. Right.
Um, and the first workflow she showed was using the MATLAB mobile app. So that one required it because she was actually getting the sensor data from the phone into MATLAB. And so the way that you do that is using the MATLAB mobile app. But if you wanted, but then she built an algorithm and then did some step counting, and that was just using MATLAB code. But then when she wanted to build an app that would run on the phone itself, run standalone on the phone, without being connected to the computer, just an app she could fire up and hit start and then start walking around. For that, she didn't need to have MATLAB Mobile on her phone at all. All she needed to have was Simulink, and she built a Simulink model and then deployed it. And once that was deployed as an app on the phone, then it would run standalone. So these are two different types of workflows. One of them is where you're constantly talking to the computer. That one uses MATLAB Mobile. The other one is where you use Simulink to build an app, and that one does not use MATLAB Mobile.
One question, Dan, related to that. There's a workflow that is based on MATLAB on the cloud, right? Related to the MATLAB support package. I did not cover that at all today, so I was wondering if you can talk a little bit about it.
Yeah, that's a great point. So within the MATLAB mobile app, you can actually connect either the to a desktop computer that's on the same Wi-Fi network that you're on your phone, or you can connect to the cloud. And so when you're connected to the cloud, it's actually using MATLAB Online, and it's using cloud service for MATLAB for running all your MATLAB code. And then you can also log sensor data to the cloud as part of that. So if you're connected to the cloud, you can actually log the sensor data onto the cloud, and that will be stored basically in the workspace of your cloud account. So if you then close down your app later and go onto MATLAB Online, you'll see that M variable, which represents the phone, and you'll be able to use all the same functions to get the logs off of that.
Right. Dan, can you talk to a use case or a example where this can be used?
Yeah, so the reason you would want to use this is anytime when you don't want your phone to have to be stuck on the same Wi-Fi network as your computer. So a really cool sensor that's on that phone is that GPS or location sensor. If you wanted to take some GPS data, say if you're driving down the street, or one time I did it where I took a bike ride around the city, I didn't want to be stuck on a Wi-Fi network that would have to be constantly talking to my computer the whole time that I was collecting that data. So this is a really nice way to get data when you're actually out and about in the real world and just on a cellular network. So you can log the data onto the cloud as you're collecting it instead of having to be connected to a computer.
Right. Great. There are some questions on installation issues. So any tips and tricks for installation issues, Greg or Dan? So one of the things I had noticed is the third party requirements. So for example, the settings on your phone, installing USB drivers. If you can do that ahead of time, that just accelerates the process. Also gathering some of the required data about the IP address of your computer and so on and so forth. That helped me get the installation done faster also. So that's a couple of tips from my end.
Yeah, one additional point I'll make about getting set up with these support packages is that, this is something that's actually true beyond even the mobile support packages to things like Arduino and Raspberry Pi. There's some support packages for hardware that don't require any additional third-party software. So some of them are just some MATLAB code and you install it and then you get that MATLAB code on your computer. And those ones you just click a button and it gets installed. Some of them require some additional third-party software, so you might see another license pop up, you hit OK, or they might have some steps to do more installation tasks after you've finished the install. So Anuja mentioned that there was a function called target updater, maybe you don't remember that function, or maybe it's going to be hard to figure it out when you're installing. Another way that you can get to that screen and perform those additional setup tasks is actually from the add-on manager. So let me just share my screen real quick. So in MATLAB, let's see, can we get my screen up? Yeah, so in MATLAB, you have under add-ons, this is where you go to get add-ons. You can get the add-ons or specifically filter to just the hardware ones. But you can also manage the add-ons that you already have installed. And this includes hardware support as well as other files that you've downloaded through add-ons. And so some of these have additional setup tasks, and you'll see, like here, I have a few of them that have this setup button on the right. So I have a Raspberry Pi one from Simulink, a MATLAB one from for Raspberry Pi, the Simulink support package for Android devices. So these will also get you straight back to that window where it can guide you through those additional setup tasks.
That's great. Thanks, Dan. A couple more questions. How many phones with MATLAB app I can use under one student license? So I don't know if the question is related to MATLAB Mobile App, or what app are you referring to. But essentially with MATLAB Mobile App, you log in with your MathWorks account. So as long as you have a MathWorks account, you can log in onto the MATLAB Mobile App.
For the Simulink case, you can create as many mobile apps as you want.
Yeah, I believe the question is about the MATLAB mobile app.
Yeah.
Right.
And so, yeah, as long as you're using your own login information, you can log in on if you have another device. So, for example, I have an Android phone which has the MATLAB mobile app installed on it, and when I installed that, I just logged into my account. And then I also have an iPad which I installed the app onto, and when I opened that up, I logged into my account as well.
Great. Couple more questions. One is, can I deploy any machine learning algorithm on my data and use it as an app? So, yep.
So what I'll say is this is a question about the Simulink app deployment, but basically anything that is supported for code generation is available to be used in this context. So not all functions that we have for machine learning are supported for code generation, but I believe a large number of them are. I think it's changing over the past few releases, so I don't know the current status.
That's right.
That's right, Dan. And yeah, so basically, it's you can free your mind and create the algorithms that you may want, as long as we support the functions and or blocks for code generation. You should be able to just go and implement whatever algorithm you want to do on your data.
Right. One last question. Do I need a newer version of MATLAB for this? So can you talk a little bit about what releases are supported and how to find that? Maybe Dan, you have your screen up. You can show that.
Let's see. So on the, let me share my screen again. Oh, I am sharing my screen. Oops. So on the page, the hardware support pages that we have, for any of these pages, if you go down to the bottom, there's generally a section for platform support and sometimes for prior release support, or sometimes they'll say platform and release support. And so this, for the MATLAB support package, is actually supported for versions R 2014A and later. And actually, if I pull up the Simulink support packages, so some of the different ones have different releases when they started, but there's actually a table on some of these pages. I guess it wasn't linked from the previous one. There's a table that goes for all of the support packages that we have from all of the different products and tells you what releases they're supported on, what platforms, Windows, Mac, Linux, 64-bit, 32-bit, and
I can bring up the page,
when they're
Dan,
first
if you want.
available. I think I have it up right now.
Oh, you have it. Okay, good.
Yep. So you can see Android
Yeah, we got
sensors
it.
started in 2014A for MATLAB and for Android and for iOS sensors. The Simulink support packages for Android was first available in 2014A, and for iOS devices is first available in 2015A. And you can see the Simulink support package for Apple iOS devices is only available on the Mac platform.
Yeah, we continue enhancing these support packages. So yeah, for the latest features, you definitely want to try to get the most recent version. For example, for the webinar and example project that I was showing earlier, you need at least version release 16B in order to do this. I'm sharing my screen. Okay. Yeah, and you will find that in many of these you will find the specification that you need a certain release to implement the functionality. That helps.
Yeah, thanks, Greg. And Dan, I think we'll close with couple of quick questions about Raspberry Pi and Arduino integration and how it has been used. I think, Greg, you touched upon it a little bit in your portion.
Sure.
But if you can talk to how to install the various support packages and to get the integration working with Android or iOS.
So to install the various support packages, what you need to do is to go to the add-on explorer and find the support packages that work with Simulink. Let me pull out here a MATLAB. In the meantime, so we have. Am I sharing my screen now? Not yet. Here, share my screen.
I think Dan is sharing right now.
Okay, can you see my screen now? So basically, let me open the add-on explorer. So if you open the add-on explorer, you will see that there is a series of support packages that are supported from Simulink, and so you will see that there is a few with this icon that runs on the hardware. If we look at Hobbyist Maker and mobile, I think this is not what I'm looking for, but yeah, you will see that we have the Simulink support package for Android, for Raspberry Pi, so for Arduino, Raspberry Pi, as well as Lego EV3. And all you need to do is to go to one of them and install it in the same way, and you will get a series of blocks in the library that will let you, when you, let me see, if you open the library browser, and this takes time. Let me take a couple seconds here. Okay. You will see that the support packages for Arduino, for example, include blocks for the Wi-Fi shields, and it lets you send and receive both TCP/IP and UDP messages, and those are the blocks that you want to put in your Arduino model to communicate with any other hardware. Similarly, if you go to the Raspberry Pi one, you will find other blocks that are related to the Wi-Fi. You can send UDP messages, TCP/IP messages, as well as receiving those messages, and these will be the blocks that you use to transfer data from the Raspberry Pi and to the Raspberry Pi. And all you need to do is to configure the IP addresses correctly and the receiving port, as I explained in the webinar.
Thanks, Greg.
Yep.
And with that, I think we're ready to close the session now. Thank you all for your questions and comments. And remember to sign up for the mobile devices challenge that we mentioned earlier. There's still a month to create an interesting project and share a YouTube video on that.
Hey, Anuja, before we go, do you think we could just share one more time how people can get more information about this challenge? Because we've provided a lot of information, lots of different examples, and all the information that you need to find all the links to web pages and things. are available on this page for the MATLAB and Simulink Mobile Devices Challenge.
Sure,
Um,
Dan. Do you want to do that? Do you want to share your screen and quickly give them a tour of that page?
yeah, so I have the screen up
That'd be a
right now.
great way to conclude.
Yep,
Yeah, I
I
think.
have the page up right now, and I think
Okay.
you're seeing my screen. And the URL, the quick way to get to it is actually just to go to mathworks.com/student challenge. Now it's called student challenge just because that's kind of the web area that we usually host these types of competitions. But actually anybody can enter, even if you're not a student. So don't let that put you off if you're not a student, but you still want to try this out and see if you can win some money. Uh, and there's a video that gives some information. There's a button to submit. But more importantly, if you scroll down, there's all the information and deadlines about how to enter. And then under the section on challenge resources, there's lots of different examples about all the different workflows that we've shown today, including videos, articles, examples from documentation, information about the different support packages that we showed today. So anything that you want to learn more about, this is the place to find it.
Perfect. Thank you, Dan. And thank you all for your participation and questions. Thanks. Bye.